Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 34 of the 2021 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, we have quadratic function h here, used to model the height in feet of a rocket from the ground t seconds after it was launched. All right, so it starts on the ground right here. I guess it's the origin. It goes up, and then it eventually comes right back down. That makes sense. Lands again. So this is a real-world situation. And so typically, right, in most of our parabolas, we would, if we want to extend this outside of quadrant 1, we would have the ability to have negative x or y values. But since this is a real-world situation, we're going to stop at the ground. Unless it lands in a hole somewhere, we're not going to go below the ground. Okay, so we're looking for the maximum value of the graph of the function. Okay, so when we get to this point, sometimes they're going to ask you for the minimum, sometimes they're going to ask you for the maximum. They're both asking for the same type of thing. Here's the difference. You have a minimum value when the graph opens upward. Right? So when we have a positive a, and that means we have an upward facing graph, we're looking for, okay, what's the lowest y value of that graph? And then what we're looking for is a maximum value. That's because we have a downward facing or downward opening graph. That means we have a negative a, because it's the positivity or negativity of that a that actually tells us whether it opens up or opens down, right? And we're looking for that maximum value. So where is it that it goes? Right there, the highest it goes. And the reason we know that the minimum and maximum deal with these are both y values. We know they're not x values because, now this is a real world situation here, but let's extend, right, let's extend this graph down just a little bit. You notice that it's spreading out. So normally this is going to be the x-axis, right? And this is going to be the y-axis. They've got t and h of t. That's fine. But if you imagine this graph, this is just a standard parabola expanding out and out and out, there's no way to get a maximum or a minimum x value, because it literally is going to stretch for infinity and it's going to get bigger and bigger and bigger and bigger. So the domain, right, which is the x values, right, that's going to be between negative infinity and infinity. So the minimum and maximum, we're dealing with here the range. And we're actually just looking at what is that maximum value right up there. So it looks like that's my vertex right there. And if we were looking for the x value, it looks like it's about 3.75. So if we want to write the vertex, we would say 3.75. That would also be my axis of symmetry, if I wanted to write that, because my vertex is going to be a combination of the x value is the axis of symmetry and the y value is the minimum or maximum. In this case, we're looking for the maximum. It looks like that goes right over to 225. So that's my vertex, and my minimum or maximum value is actually the y coordinate within that. So we would just go ahead and bubble it in. 225. I mean, it's just right there on the graph, and just make sure we bubble in 225 correctly underneath that, and that is our answer, 225.